By now, you've probably realised that engineering is no longer what it used to be. It's now evolving to be a whole new area. Some of the people that you've met so far, some of the people you've listened to so far, should have really opened your eyes to the idea of that engineering is now a bigger, vast area for you to get involved with. Take a little bit more time, let's meet somebody else, and let's see how they use engineering humans in their places.
So my nickname is Bill. My real name's William, and my last name is Balot. Don't try to spell that. That's a tough one. And my job title, I actually have two of them right now. I'm the Director of Global Exotechnology Programs, and I'm also the Executive Director for the Exotechnology Center of Excellence for ASTM International. My job titles are Director of Global Exotechnology Programs and Executive Director for the Exotechnology Center of Excellence. So both of those titles is about exotechnology. So what's that? So for us, it means exoskeletons. So wearable devices that help you, whether that's to help you perceive or move physically, or to aid you in being able to do something better than what you can now. And so my titles are really about being able to run programs underneath that area. One of those programs is the Exotechnology Center of Excellence, but the reason why I have sort of the title of Global Exotechnology Programs is the idea there may be other programs in the future. Any job that is a manual labor type job is really what exoskeletons are kind of intended for in sort of the industry space. They're also intended for sort of the medical rehab space to help you either get better when you are injured, or they're there to give you the capability to get closer to where you were before you got permanently injured. And this is all I'm talking about. What is the potential of exoskeletons? Because each one is kind of different. And what is an exoskeleton? I keep saying that word, but it's something you wear. It's sort of like if you were going to an interview, you would wear a suit. Well, an exoskeleton is kind of a suit to help you do something better, whether that's just mobility where you're walking. It may be a suit you kind of wear if you're doing what they call overhead work. A lot of automotive places do overhead work where you have a car moving over your head and you have to do something underneath it. And so the exoskeleton is helping hold your arms up. So you're not having to do all the work of doing that and doing whatever you need to do underneath that car. So that's really what we mean when we mean exoskeletons. It augments the human in some way. And that augmentation may be to kind of help you do something you already do better, or get you back to closer to what you could do before. And so that's why it has a lot of application, everything from medical to industry to military to construction to agriculture, a lot of spaces like that. So in this particular with exoskeletons, really I got into this about specifically I'd say 5 or 6 years ago, but I would say almost from the near the beginning when I was working on my mechanical engineering degree. I kind of got in this area of what I call this intersection of biology and engineering. So I was in mechanical engineering, as I've said before. I took an elective class in biomechanics, and I was just fascinated by the idea of this applying engineering to all these biological systems. And that sort of led me on this path where here I am now working with exoskeletons, where you're combining engineering and biology to help solve problems. And so that solving problems is another area that I've always been attracted to. Yeah, so one of the things that's very satisfying about my job is I get to help others. So, and that's everything from working on things that help a specific individual to helping organizations. You know, one of the promises of exoskeletons is, you know, you're your family member, whether it's your mom, your dad, your brother, your sister, whoever, they shouldn't go into work and come home broken. They shouldn't have to self-medicate when they get home so they can go back the next day. And so we work a lot with people in sort of the ergonomics profession. We work with the Human Factors and Ergonomics Society and many others in that area because they see a great promise in the exoskeleton area to help people going into work to come home just as healthy as when they went there. And certainly there's a lot of promise in the medical rehabilitation area. Exoskeletons are used a lot. People who've had spinal cord injuries or strokes. And there's probably other types of conditions that exoskeletons are going to be available for in the future. We're looking into it for a return to work scenario. So say you hurt your shoulder or your elbow or your knee, and instead of being out for, 2, 3 weeks, maybe you can come back a little bit sooner with an exoskeleton. And so, I get to help people, and that's a really cool thing. What skills are needed by engineers and STEM people? So technologists, engineers, mathematicians, scientists. So one of the things that we see all the time is this ability to understand and integrate across different disciplines. So it's great that you have some expertise in a particular engineering area, but you should also develop some awareness of other areas because most of the really big challenge these days are across discipline, as they say. And the other thing is this really huge thing, whether you're a STEM person or you're just any other type of career field, is this ability to collaborate, being able to work with others from a different area and to integrate that into what you're trying to achieve. That's huge. That's where I'd say people should focus on develop their expertise in the areas that they like, learn how to work with others, and bring a positive attitude to the challenge. We have a lot of people who are great at identifying what the issue is or what the problem is. Sometimes we need more people who are like, okay, not only am I going to identify the problem, I'm going to actually help fix it. And so that kind of attitude, coming to the table with that can-do attitude is huge.
So if you're not excited about what you've seen already, I'll be surprised. Some of the things that are going on in the world are amazing. Some of the engineers, some of the different peoples from science, technology, engineering and mathematics are amazing what they've been doing. This fun never stops there. This evolution just keeps going on and on and on. It's extremely exciting. But before I go on too much, let's speak to some more people from the industry, people who really do this as their job, and let's see how they use engineering in their workplace.
So I'm Donald Peterson. I'm the Dean of the College of Engineering and Engineering Technology at Northern Illinois University in the state of Illinois, United States. The university is located about 60 miles west of Chicago, which is a third largest metro in the United States. We're surrounded by a lot of industry and a lot of need for engineering and a lot of need for engineering technologists, for students to come into engineering and be able to be placed within industries, and very exciting industries, from medical devices to manufacturing to advance research and development for corporations that have a very large international footprint within this area. I'm also active in research, particularly in exoskeletons. I'm currently the chair of ASTM Committee F48, which is the Committee on Exoskeletons and Exosuits. My work in exoskeletons started to build exoskeletons that would help hemiplegics, or folks that would be essentially impacted from a stroke event, where one side of their bodies paralyzed essentially after experiencing the stroke. The exoskeletons that I initially worked on was funded by NASA, which what is their interest in exoskeletons for rehabilitation for stroke victims? They do have an interest in that, but it was primarily to look at these same types of exoskeletons that could be used in microgravity environments, namely the space station, to be able to provide resistance training to large joint structures in microgravity environments. So I was funded by NASA as well as some students that I had to be able to build a low-cost rehabilitation exoskeleton that can be used with stroke patients as well as astronauts. That essentially started my experiences with exoskeleton technologies. My background is in biomedical engineering. My PhD is in biomedical engineering. Um, but I probably should say that I'm mostly focused on biomechanics and mechanical systems or mechanical aspects of the human body, which allows me to take the principles of mechanics and be able to apply them to be able to assist humans in terms of their motion, assist in terms of designing better devices for humans, like exoskeletons, whether they be for rehabilitation, whether they be for training in microgravity environments, or for protective devices that, like exoskeletons that could be used in industry or even the military to augment performance and enhance strength under safe conditions. So a typical day for me is quite interesting. So as a dean of a college, it's really essentially like being a CEO of a company. So there's a lot of administrative responsibilities day in and day out. I can't tell you the amount of emails I get and the email traffic that I have to attend to on a daily basis, as well as working with faculty, staff, and students on various issues. In addition to this, I do have an active research program, namely in exoskeletons, that I also keep moving on a day-to-day basis. And I have a faculty member and a postdoctoral faculty member who's working with me on advancing that research. So I constantly are in touch with those individuals in the laboratory, including students that are working with me in the laboratory, whether they're undergraduate or graduate students, or even high school students. So we've occasionally taken high school students who are interested in learning more about exoskeletons, for example, to come in the volunteer time to be able to participate in the work that we do and be able to advance our understanding of the technologies that we develop in the laboratories here. So my day is quite packed. I don't think there's enough hours in the day for me to be able to do what I want to do, but that's a good thing. It keeps things very exciting between my administrative role as well as my research role. I also do get involved in teaching too, which I enjoy working with students and being able to pass on knowledge and information that I've gained to students. So in hopes that one day they'll be a impactful engineer, and even an engineer that's much better than I ever could imagine I could do. At a young age, I used to take things apart. Let's start there. I know my parents, who were not, we were pretty much lower class in terms of parents didn't make a lot of money. But when they would buy me an electronic game, handheld game years and years and years ago, or some other types of device or fancy toys, and not like today where I have kids and spoil them with a lot of different toys, where I got maybe one big toy a year, for example, at Christmas time or my birthday, and I have to take it apart. So that used to frustrate my father, I can remember. But I get it back together, working again, but I had to see how it worked. As I grew older and started to learn more about math and science and how I could apply those and understand those more so that they could be used to help me understand when I'm taking something apart, how it works, or how somebody ended up designing or using that knowledge to be able to design something. So I got quite excited about the fact that scientists learn about how things function or why they do what they do, and engineers take the science and mathematics and not only study how things work and what they do and how they do it, but then to also take that information to be able to build better things and engineer something. So I got quite excited in that, and as I got into my high school years, I looked at what I could do for the math and sciences, making sure I was always on the cutting edge of mathematics, and if I didn't get something, is to go find the help right away. Same with the sciences, make sure I was in the advanced classes for chemistry, biology, physics especially, and then again, wasn't afraid to embrace the opportunity to get some help if I felt there was a particular problem or principle I just wasn't grasping in the lecture. Um, so what got me into the STEM fields, again, was to be able to affect a purpose. Take the information that I'm learning, not only in my tinkering, but also in the coursework, and be able to really provide a change. And that's actually one of the reasons why I wanted to biomedical engineering. I wanted to be able to um, research and develop things and be able to see those things in action, and seeing how it could change people's lives. Yeah, I think the biggest advice, as I mentioned earlier, was to first grasp the changing world around you, and understand that it's going to continue to change, and probably at a faster rate when you're at my age now, for example, than you're seeing today. And it's going to be a non-linear increase. I think it's just going to get exponentially in terms of momentum and how technology changes. Um, I would recommend students to go and see if you can spend time in companies, volunteer. Go to see, if you're interested in a particular STEM area, whether it be manufacturing or exoskeleton development or exoskeleton use, for example, or just some other aspects of STEM or engineering, is go to the company and see if you can volunteer time to see what engineers do and how engineers make a change in society and in that industrial community, for example. Go to your university, local university, find a researcher or a faculty member who's doing various aspects of development of STEM within their laboratory and their environments, and see if you can volunteer. As I mentioned earlier, we see a number of high school students who do want to spend time in our lab, ultimately get to get hands-on experience, because most of these high school students who come and volunteer in a laboratory, instead of just shadowing and watching things, they actually have skills in programming, building, using 3D printing or printers, and so forth. So they rapidly take on a role within the environment. And I would recommend that to any high school student or even middle school student, is to go and volunteer and even shadow and see what's happening out there in the currently in the industrial or the academic environments.